Recently, I read a novel where there was a debate going on between a priest and a scientist. And at one point in the discussion, the scientist said to the priest, "You state your faith, and I'll give my reason." And he set forth the debate between them in terms of a dispute between faith and reason. Not altogether unlike some of the differences of opinion I've had with my wife, where she sometimes complains, and she said, "I can't debate with you. You always want to resort to logic when I just know that this position is false." And I say, a man with logic is never at the mercy of a woman with intuition. And so we have our own little disputes following this same kind of disjunction. But this seems to be the perception that we have today, that theology involves a leap of faith, where science involves a cogent, relentless pursuit of rationality, as if faith and reason were completely divorced one from another. It also raises the question of method. We say there's a method to his madness. Well, every investigation of truth, whether it be in the realm of theology or philosophy or science, involves the application of some kind of method. And that method may or may not include a dependence upon reason. Now, in our first segment, we talked about the enterprise of both science and theology of being concerned with salvation. The overarching salvation for the scientist was to save the phenomena as Plato suggested. And I talked about a revolution that took place in the 16th century with the theories postulated by Copernicus in the so-called Copernican revolution. Now, as I mentioned, there was this fierce reaction from the church. Galileo was placed under the papal ban, but it wasn't just the Roman Catholic Church that reacted against Copernicus and his theories. The nascent Reformed movement that had arisen in the 16th century also positioned itself squarely in opposition against Copernicus. The two magisterial reformers of the 16th century, for example, John Calvin and Martin Luther, thought that Copernicus's theories were ridiculous. Now, the question is this: why all the fuss? People believed that the integrity of the Bible was at stake, and that human opinions were now going to supplant divine revelation. Now, the question is this: why did the theologians of that day think the integrity of the Bible was at stake? Well, if you look at the teachings of Scripture and what they say with respect to nature and natural phenomena, we read, for example, in the Bible, descriptions of the sun moving across the heavens. And it very much seems from the literature of the Scripture that the Bible is endorsing a view of cosmology, a view of astronomy and physics that suggests that the earth is stationary and the sun is moving in orbit around the earth. And so if we accept the Copernican theory that it is the sun that is the center of the solar system and not the earth, you can see what happens to the credibility of the biblical documents. That's why the debate was so severe. Until people calmed down a little bit and said, wait a minute. When the Bible describes the external world, when the Bible discusses the phenomena that we observe, it uses a kind of language that we simply call phenomenological. Or, in simple terms, the language of phenomena. That is, we describe things the way they appear to the naked eye. And of course, biblical writers, when they're describing the day as they perceived it, would talk about the sun crossing the heavens. Because when we're standing here on earth and we look up into the sky, what do we see? What's the phenomenological experience we have? To the senses, it looks perfectly clear that the sun is moving and we are standing still. Right now, as I'm speaking, according to modern theory, I'm spinning at an enormous rate of speed, and I'm on this orb, and I don't know whether I should be right side up or right side or upside down at the moment, which end of the earth I'm on at this second. And common sense would say that if the earth is round, then you can only live on the top of it, because anybody that was destined to live on the bottom place of the planet would fall off. Or if it's really spinning around on its axis, we'd all be dizzy all the time. That's what we call common sense. How's the word sense used there? That is, it's the common, universal, phenomenological sensation that we all have. Now, do you really expect the biblical writers centuries ago to expound technical, abstract, scientific theories? Their basic concern is the work of God in history, the work of God's redemption, the work of His promises that take place in this sphere of the natural world. But the operations of the natural world are described in phenomenological language. Now, somebody might look at me and say, oh, this is special pleading. You know, you're going through all these gymnastics to save the integrity of the Scriptures. No. I'm trying to save the integrity of language. Language as we use it in ordinary discourse. I frequently use the illustration of watching the daily television broadcast of the weather. They don't even call it the weather forecast anymore. Now it's the meteorological survey. And the weatherman has to have a degree in meteorology. That's an interesting word also, because it goes back also to the ancient world and the ancient world's understanding of the way in which meteors affected the weather. But nevertheless, we still use this language of meteorological survey, and you see the weathermen get on television and they put up these charts and they show high pressure systems and low pressure systems and barometric pressure and the precipitation probability quotients, and all of this technical jargon is used when all I want to know is, do I take my umbrella to work or not? But after all of this technicalia, at the end of the weather forecast, they have this little recapitulation where they tell you what the day's weather will be like, and then they add sun up, 6:45, sunset, 6:23 p.m. And what do? We rush to our phones and we call our local broadcasting company and we say, haven't you guys heard about Copernicus? Are you still trying to convince us that the sun rises and the sun sets? What madness is this, that we have been blinded for all these centuries to the clear and certain conclusions of Galileo and Copernicus and all the rest? Now, nobody complains about that because we understand that we're using the language of phenomenology. Now, when we come to science, one of the most important breakthroughs that occurred as a result of the Copernican revolution was some fine-tuning in the method of approaching the data of scientific inquiry. And what we all learned when we were children in school was a simple summary of what's called the scientific method. The scientific method. And when we look at the scientific method, we see that there are two critically important, distinct elements that are married together in the quest for truth. And the two important elements that together comprise the scientific method are what we call induction and deduction. Sometimes this is called by another name, which name is the analytical method. Sometimes we describe our culture today as being postmodern or post-enlightenment to give us kind of a benchmark for where we are in the continuum of history. And we think back to the 18th century Enlightenment, that which was called in Germany the Aufklärung. One of the elements of the Enlightenment was the setting forth of a methodology for approaching questions of truth, which was called the analytical method, which was simply a sharpening of the classical scientific method. The analytical method defined itself in these simple terms, that it is the task of the scientist to discover the logic of the facts. Let me say it again. To discover the logic of the facts. I once had a consultant who said to me, if you're going to make decisions in your operations on how you're going to allocate your resources, you need information to make intelligent, informed decisions. You need the right information, and you need a sufficient amount of the right information. And he said this, and he was absolutely right. If you get enough data, assuming that the data is accurate and it's the right data, he said the decisions jump out at you. What was he saying? He was simply applying the analytical method. He's simply saying you gather all of the data that you can, get as many facts as you possibly can garner together, and then see if patterns emerge. See if there's some logic that is beginning to take shape. This is what we do in the scientific enterprise. And so we use both induction and deduction. Now, we all remember when we were children, we learned the difference between induction and deduction. That is, we remember that when we were children, we learned that distinction. That doesn't mean that we remember the distinction. Some of us may stumble in trying to articulate the difference between induction and deduction. In simple terms, it's this. In the process of induction, what we do is that we move from the particular to the general. That is, induction is involved by experimenting, observing, gathering of materials, and so on. We look at one squirrel and we notice the squirrel has a bushy tail. Then we find another squirrel and that squirrel has a bushy tail. And then we look at a third squirrel and it has a bushy tail. And we do this until we get thousands and thousands and thousands of examples of squirrels. And we look at all these particulars, and we know we don't have the time or the ability to examine every conceivable squirrel that ever lived or could live in the universe. But then we are now inclined to generalize, and we draw a universal conclusion from the particular data bits that we've examined, and we come to the principle what? All squirrels have bushy tails, unless one got cut off by a lawnmower. But we move inductively from the data of our experience that we measure, observe, collect, analyze, and then come to our conclusions drawn from what we call the facts. Now, that's one pole of the scientific method. The other part of the scientific method involves deduction, which involves the moving from the general or the universal to the particular. The most famous example of this is the syllogism. And the most famous example of the syllogism you also learned when you were in elementary school. All men are mortal. Now, what kind of a statement is that? All men are mortal. It's a universal judgment, okay? You're making a statement about everybody in a particular class. All men are mortal. Socrates is a man. Therefore, what? Socrates is mortal. Now, is that a true argument? You're looking at me puzzled. The answer ought to jump out at you by now. Is it a true argument? All men are mortal. Socrates is a man. Therefore, Socrates is mortal. Is it true? No, shake it this way. It's not true. Arguments are not true or false. Arguments are either valid or invalid. Propositions are true or false. I fooled you, didn't I? Okay. Now, is it a valid argument? Yes. The argument is valid. The conclusion may be false, even though the argument is valid, because the conclusion rests upon the truthfulness of the premises or the propositions. Do we know for sure that all men are mortal? Some of you are shaking your head. No, we don't. We don't know it inductively. Have we examined every human being that ever lived, make sure that they died? What portion have not yet died? All that are still alive. The only way you can know for certain that all men are mortal is posthumously, because even if you're the last person alive on this planet, you may be the lone exception. But we have a reasonable selection, a reasonable universe of particulars to draw the inference or the conclusion that all men are mortal. If that statement is true, if all men are mortal, and if Socrates is a man, then what about the conclusion? Certain or uncertain? Absolutely certain. If all men are mortal, and if Socrates is a man, then it follows by necessary consequence that Socrates is mortal. Now, this is the deductive side. This is the side that makes use of logic. Induction is the formal side. The material side. Induction involves using the five senses and instruments of sophistication like microscopes and telescopes and so on to observe the particulars. And we're not doing good science if we ignore the data. You heard the expression, this fellow won't allow the facts to get in the way of his argument. Or you may say, don't confuse me with the facts. They're saying there, don't give me bits of reality that may challenge my system. But true science is trying to save the phenomena. And the way we encounter the phenomena is through the senses. I don't know that there's a piece of chalk here on the basis of sheer deductive logic. I can't crawl into Descartes' Dutch oven and spin out the existence of this piece of chalk. I am compelled to believe that there's a piece of chalk here because I'm seeing it, I'm feeling it, I'm in sense contact with it. It's part of the material world, the world that can be perceived, the world of phenomena. So I examine this piece of chalk and a bunch of other pieces of chalk, and I try to see if there's some kind of built-in chalkiness that has logic to it. Now we're going to look more about the role of logic, in science, but the crisis today, in my opinion, between theology and science, and what I hope to show, is not so much a crisis between faith in theology and reason in science. I'm convinced that the crisis is deeper than that. I'm convinced that the crisis has to do with the relationship between faith and reason in theology, because there's a lot of irrational theology out there. I was teaching a course recently in philosophy, and I talked about the science of theology. And one of the people in my class had a doctor's degree in one of the natural sciences, and he objected to my calling theology a science. He says, theology is not science. I said, is it ignorance? He said, no. I said, well, what does the word science mean? It means knowledge. And it's a field of knowledge. There is an endeavor taking place here in a pursuit of knowledge, a pursuit of truth. And insofar as it's interested in truth and in knowledge and in reality, it's concerned with science. But we can't then, if we're going to say it's scientific, chop ourselves off at the knees and say, well, when we do theology, we can leave our brains in the parking lot, or we can abandon reason and just take these quantum leaps of faith. There's a real crisis in theology today where people want religion to be irrational. But what I also want us to see is that that crisis between faith and reason has also infected the natural scientific community, where one half of the scientific method has been negotiated, where we have created a generation of scientists who are extremely well trained in induction, but equally poorly trained in deduction. That is, where we find commonly irrational conclusions being drawn from the data. We'll look at those areas of conflict in our next session.